Hello, everyone. It's good to be back at DConf and to London. I actually did my honeymoon here 17 years ago. But enough of that chit chat. Let's get to what everybody is eagerly waiting for: payroll. So in the fall of 2016, our HR manager gave her notice that she was leaving. And one of the duties that she handled was payroll. Somebody needed to do payroll because apparently if you employ people, they expect to get paid on time for the amount agreed to. So we had to find somebody to do this. But who could do such a task? Who could accomplish this task? That person was Payroll Man. Now, Payroll Man was very good at math. He understood processes. And he was quite the looker. Yes, friends, I'm Payroll Man. So now that the company had its volunteer to do payroll, I had to learn how to do payroll. So the steps for payroll: first of all, there's a payroll timesheet. Now the payroll timesheet you print out at the beginning of every payroll, and it has a list of everybody's names on it, sorted intuitively by department, because who needs to use last names? I mean, linear search is way better, right? So anyways, we record the hours of everybody who worked, any changes to status, and basically this is what it looks like. This is an actual sheet. I've covered up the names to protect the innocent, and this is the stuff I had to write down, and as the lady was showing me, this is what you do. Where do we get that information? Individual timesheets. So individual timesheets, the workers would record the time started and stopped for each task, the hours that added up to, total hours for the day, drive time in the morning and night. We had to pay them extra if they were driving extra, and the total hours for the week. Now, why am I showing you all these different things? There's one other thing, was overnights. We paid extra if they had to stay overnight. But why am I showing you all these different things? Is because I only needed the first one. Just tell me what time you start and stop each task. I can figure everything else out. But no, they had to do the math in their head. Now, I don't know if you guys have ever done time math, especially with AM and PM. It's not easy. So to ask people who are not really math specialists or time math specialists to do this led to a few errors, as you might expect. So this is an actual timesheet. Again, I covered up the name. But you can see on Tuesday, worked one hour. That makes sense. Half hour here. This one's a little bit trickier because you're going across noon. But yeah, that's right, 6.5 hours. You add 1.5 plus 6.5, and you get 7. No, you get 8. But he put 7.5 down. This one's my favorite. He put down 9.5 hours here, added nothing to it, and got 10. So you can't just take these things at face value. You have to figure out, well, what did you actually mean? So there was a process. I would talk to the manager would talk to him, figure out, what exactly happened. This was not a quick process. So, and then I got about 20 of these. Here's another one that's filled out actually correctly, but you could see all the information on here that I had to double check. Excuse me. Next, punch cards. So that's people in the field. People in the office had an RFID punch card that they would use to punch in and out. But they also must manually write down when they punched in and out. Why? Because sometimes the thing didn't work. So what's the point of having a system that records all this stuff for you when you still had to write it down and check it at the end of the week anyway? Completely useless. And then so to shore up that data at the end of the week. Now that we have all this stuff written down on our timesheet, it's time to enter the data. So we actually copy all the handwritten stuff on that timesheet into a website, double check all the numbers by adding them on a calculator that they matched. Now, the website also didn't have any math features. It wasn't like Excel or anything. And adjust anything, adjusting terminations, salary changes, whatever. And there was other stuff. I had to calculate commissions for salespeople. Generate a report for the manager so they knew how much time off people had. Run post-payroll reports, print everything, put it into a folder, and there was just more stuff, and it just, yeah, there's a lot of stuff for payroll. So the time needed to do all this stuff was about 3 to 4 days. That's for me. The previous HR manager could kind of get it done in 2 days, but she was really good at writing stuff down and doing stuff on a calculator. I'm good at programming. The time available to prepare payroll, though, because it had to be in on Tuesday, was 2 days. So the smart math payroll man figured out that this isn't going to work. So the moral of this story is, basically, you have a computer. Why not use it? This is something I've been living by and telling to people for a while, and I applied it in this case. I don't want to write down things by hand. I want to use a computer. That's what they're good for. They're good at calculating things. They're good at storing things. We should use it. And pretty much everyone has one in their pocket. So that's the first thing I did. I created an app for time cards. This is the same timesheet that I showed you earlier, just put into the app. They always have it in their pocket. Every time they finish a job, they just go in and say, yep, I'm done. It knows the current time, so it figures out, oh yeah, I'll add that in. No more time math. This is doing all that. They always have it with them. Once it's submitted, the online representation of this links directly to the jobs they were working on. So each job has an ID. It's hard to see it here, but I can click right on that and know which job they're actually talking about that they were working on. And we got rid of the other punch card system. Now everybody uses this, and we have no more problems. The nice thing about this is I don't have to do any negotiations. By the time it gets to me, it's correct, because the managers looked at it and signed off. So, Robert is going to hate me for saying this, but the payroll timesheet I replaced with an Excel spreadsheet. Excel spreadsheet was an easy thing to do. Didn't have to write a whole program for it. And Excel is actually pretty good at tabulating a bunch of data and adding things up in rows. So this is kind of what you're doing. And I use a VBA macro to generate a CSV that then is able to be put right into the system. Oh yeah, I know. It's not that great. I'm planning on fixing this at some point. But in any case, this is a lot easier than manually typing in the things that you added up by hand on a piece of paper. One button push, payroll is ready to be generated. And all the totals are calculated instantly on the Excel spreadsheet. You can compare with what the payroll system said to make sure everything's there. Now, how long does it take to run payroll? 4 hours. So it went down from 4 days to 4 hours. You have a computer. This is why you should use it, because this is what it does for you. Now, what does this have to do with D? To me, I feel that D has the same kind of transformative power that computers have over paper when it comes to generating boilerplate. When you can generate stuff instead of writing it, it's so much easier to deal with. So I like to change this from, you have a computer, why not use it, to, you have a decompiler, why not use it? Let me give you a simple example. So let's say we have a record that we're going to deserialize from a database. Doesn't matter what the database API just kind of made. This is not real code. So record accepts a row. We create a result. We parse the integer field. We parse the name field. And we return the result. All right. But does it work? Does anyone see a problem with this? Yes. What is it? Typo, right. I typed main instead of name. I did that on purpose, but just for the demonstration. I would never do that in real life. But this kind of shows you, like, why did I have to do that? It's right here. I already know what it is. I shouldn't have to copy that twice. Imagine if there was 50 fields and I had to do 50 of these lines. It's awful. So let's go to a generative approach. So these are kind of the three major weapons that D has to generate code. Static for each, or for each over a tuple, same thing. But static for each, to me, is the big game changer. And the reason is because, and you'll see it after this next example, the reason is because you write it like you think. We have traits as std.traits, gives you all kinds of good information, and static if, of course. So those are the three major things that help you generate this boilerplate. So in our generative function, we have a record, same thing, we declare the result. Now we import std.traits so we can get some information. And what we get is a field name tuple, which is the names of all the fields in that struct. And we're using static for each. So each thing inside here is instantiated separately for each member. We're going to assign the field to the exact conversion expected. So before I was saying get integer, let's assume that the database API has this get with type. If it doesn't, I'm going to write it to wrap that. But in any case, this is the whole function. Now this works with our simple thing. There's no typos anymore. And if that struct changes, or if you want to do it on a different struct or whatever, I don't have to change this. It's all done. I don't have to write any of this boilerplate again, which is awesome. Now let's look at a more complicated case. Here I'm defining some enumerations, record type, permission. Who knows what the database engineer is going to stick into that stupid database? You know, permission's a bit field. We have a point, and I put it all in here. Okay. So you notice here I have little comments. Okay, that's stored as an integer. The record type stored as an integer in the database. The location is stored as location X and location Y, but only if the type is location. So there's all kinds of little conditions for these things. So doing our manual function again, we declare the result. This is the same as before. We're getting as integer, get as string. We get it as a record type. Now we get it as an integer, and then we cast it. Point location. So this checks first, are we a location type? If so, get it out. Otherwise, they're going to be null, and you're going to possibly have an exception or whatever when you try to get that. Only store the comment if it's present, right? That makes sense. And now I've done some range code. I actually don't even know if this works, but I think it would. But this basically some stuff you write just to get it to work. This is kind of like a handwritten function. And we avoid keyword collision here. So we have the real name of this thing is class in the database, but we can't use that as our thing. So we have to, use the correct word, string. Now, there's a bug in here. Does anyone see it? I'm kind of tricking you because there's no way you're going to figure it out. But can you see it now? So some idiot put Y in front of X in the structure, which nobody would ever do, but for the purpose of this, I did it, because you never know. Somebody's going to do something like that. But, the compiler knew this information. It knew the order of the stuff. But we had to tell the compiler, put this in this place. We shouldn't have had to do that. So let's look at a more generative approach to this. Instead of comments, we're going to use UDAs. So the benefit of a UDA over comment is the compiler can react to them just like we react to comments, but it has all the information it needs. And they're just as descriptive. So if we look at our struct again, we're going to replace these one at a time. So we have this record type says stored as an integer. Well, I'll just put a UDA in there. That's fine. Location, only stored if the record type is location. or I mean, this is just I didn't actually write these UDAs, but they're all writable. You could do these things. And here we're giving it a lambda. The comment is optional. No, we just put a tag on DB optional. It's just as readable as the comment. This one, well, we just have to make a specialized function that does that one anyways. So, but we can do that. This is like an escape hatch where you say, okay, this one member, I want to do this weird thing that, you know, the library isn't going to support. And finally, you know, you just keep going. Just add UDAs where you need them. This is the same struct. It's basically the same information. It's just now the compiler can read the data. It can read those comments. So if we go through the same function, same thing as before. Now I'm using normal for each, and you'll see the y in a second. It's because static for each doesn't have the ability to continue. So normal for each, I can say, okay, this guy's, you know, null or is option or whatever, just continue to the next guy. Otherwise, we're going to keep going. Same thing here. We're calling the lambda saying, you know, only if this lambda is true do we parse it. And this one just says, okay, so if we have a custom function, we're going to call that instead of the real thing. Otherwise, we're going to read it, but we need the right type. So check to see if there's the DB type UDA. And if not, just alias the type to read as the type of the actual member. And check for an override. So this is for that case where we had the class member. And finally, we just do the actual read based on all those things we set up. And that's it. We're done. Now this, like the other generative function, works with any single struct that you have. You know, it could be as complicated or long or whatever as possible as needed, and I don't have to write any other code. The compiler is doing everything for me. It's kind of like you're teaching the compiler how you would write the code. And the reason I said before that I think the static for each is so important is because when we did the manual function, that's how we thought about it. Oh, what's the first member? It's an integer. It's an ID. Okay, now to go to the next member. Oh, it has this comment on it, say it's optional, whatever. That's kind of how we would approach it. So it's readable code as opposed to other languages might do that. So let's do a comparison. The generative is 41 lines versus 21. But again, I only have to write it once. And if the struct gets bigger, that manual function is going to get bigger and has to be maintained, whereas the generative function just automatically adapts to whatever's in there. The generative is drier than manual. I don't have to repeat myself. You know, you don't say your names twice. The generative function doesn't need updating, as I just said. And this is the other thing. If you make a mistake in your generative code, it usually blows up really loudly during compilation, whereas manually you have you know, a chance to write bugs in every single line, and they're usually more subtle. Like the thing with the location, that's corrupted data, you know, if you wrote them out of order. Mixins and CTFE. So with mixins and CTFE, D has a lot of power when it comes to string manipulation, and most of it is available in CTFE. So you can actually generate the real code that you're going to, you know, pretend I wrote this code and include it. There's some disadvantages there. It's more difficult to follow than the generative template, but and more difficult to debug because you're working with code that isn't actually listed there. But it does allow for more modular usage, so you can basically generate the string in one place and use it in multiple places. Let's look at kind of how other languages approach serialization. Java. Java is statically compiled, so that's good. But it supports generics, not templates. Everything you do in Java that is introspection is runtime introspection. So this is how it works. You have an interface, serializable, with no methods. You put that on your class, and now it's serializable. Why is that? Well, the reason is because Java uses reflection for introspection. So it's not even going to use an interface. It's just going to use reflection and find each member and say, oh, that's an int. I'm going to serialize it this way, whatever. But the interface has to be on there because Java serialization has to access the private data. So basically, it's like a gentleman that says, I'm not going to touch your private parts. Unless you give me permission, then I'm going to touch them here and over there. So basically, it's just a tag. And there are some other hooks. You can define certain functions. If it sees those functions as defined when it's doing the introspection, like let's say I think it's a serialize to or output save or load or something like that. It's going to call those functions, but there's no static checking of that. If you misspell them, it's just not going to use that. Optimization has to rely on just-in-time compiling because, of course, here we're doing runtime stuff. But even that, you're still going through the reflection, which is much slower. So, I mean, D has much better, even though it's similar, where you're not doing much effort to be able to serialize something. Customization is horrible. You got to write your own function that does everything, or as opposed to D, where you can use like UDAs. But it works. It's not bad. C or C++. So C++ has good generative template capabilities, but not as useful introspection capabilities. So you can't see as much information about a type as you can in D. And there's not really a good way to loop through members. So that static for each is a killer feature. Basically, this is how I looked up Boost's serialization thing, and this is how it works. Basically, you define a save function, which takes a templated archive type, and you can't just call a function on that archive type to do a member. No, we're C++, we have to use operators. So we define an overload for and yeah, that looks great. The sucky part about this is I still have to go through and tell it, serialize this member, serialize that member. What about XML or JSON? There's something missing here. What's missing is I'm serializing the data, but not the names. So they have this 15 or 20 letter macro you can use to surround the X, and then it passes both X and the name X to the function. And then you can serialize XML. Now, its main focus is to abstract the archiver, not your stuff. It doesn't generate your boilerplate for you. It just makes it so that you can use different archivers with the same function. And you still have to define how to serialize all the members. So, I mean, D wins here for sure. I'm sure there's probably somebody who's going to figure out a way to do what D does in C++, and it'll be horrendous, but, it's just not the same. What about C? So C has no introspection capabilities, but it has the preprocessor. So there are ways to generate boilerplate this way, but funnily enough, I found no projects that do that.
Oh, GTK does it.
GTK does it? Okay, so there you go. So there's some specific projects that do, but I couldn't find any. Most serialization were just focused on the serialization format and getting that right. You still have to make all the calls, serialize an int, serialize a double, whatever. But not ease of just taking a type and saying, serialize this thing like I would do it. So I wanted to show some progress that I've made on IOPipe. So IOPipe, I did talk a couple years ago, is an IO processing library, basically trying to make things as fast as possible. And one of the examples I had was a JSON parser. In that talk, I talked about the JSON, basically transforming it into a pretty printed JSON, how fast that was. But since then, I actually added some serialization capability to it. So let's I'm just going to quickly go through this. This is kind of how you use the parser. You take any IO pipe, which a string is an IO pipe. So you take an IO pipe, make a tokenizer out of it. Then each token it gives you back tells you what it is. So first thing is going to be the object start. Then the next thing is going to be a string, which is ID, and then there's a colon. So this is simple stuff, right? So this is just so you can understand when you see the code in the next few slides, like this is how it works. Anyway, so you get the data directly from the buffer. So let's look at how deserialization is implemented. So we're using template overloading to select how to deserialize each piece. Primitive types are easy, just use 2. I have a string, I use 2, I get the result out. Integers, floating points, some of them are like, and I think the Booleans, like true or false, I just know, oh, it's true, so I'm going to do true directly. Arrays, we loop and recurse. We read the opening brace and we say, okay, each value, I'm going to recurse for each one. Objects are the most interesting one. So that's the one I'm going to show you. But you can also use loop and recurse because we have static for each. So let's define some UDAs. Serialize as basically says, I want you to use this member as the representation of me, kind of like a alias this. Ignore says, don't serialize this, it's not part of the JSON state. And optional says, if you don't see this, it's okay. Otherwise, it's going to throw an exception saying you're missing this piece out of the JSON. So this is the escape hatch. If you define your own function from JSON, it's just going to call that and say, there you go, you got it. Otherwise, this is some template constraints that allow me to do nullables differently, or JSON value, which is like a DOM representation. So first we'll check to see, does it have a member that it's supposed to represent it? And if it does, then it's going to use that as the implementation. Otherwise, we're going to expect an object. So all members basically gives you a list of members, just like field name tuple. In fact, it uses that. Otherwise, but it's going to ignore ones using filter. It's going to ignore ones that have the ignore UDA attached to it. So basically, any type of thing that's going to select what I want to serialize, I can add it to this template, and it does the same thing. Now we have a visited array, which is basically because we're parsing the data out of the stream in the order it comes in the stream. With JSON, it can be in any order. Remember before we were parsing a row, the row already had all the data, and I could ask the row, do you have this piece, do you have that piece? Now we're going to parse it in the order of the data. So we're going to use our static for each in a slightly different way. So first of all, in order to allow optional, we just say we visited those. So if they don't show up, it's okay. Special case for no members, so if there's no members in the object, I don't know why you'd want to serialize that, but it is in there. And then this is some standard parsing fare. So let's pull off the name, let's pull off the comma. Basically we're dealing with the tokenizer, and this is it. This is the whole function, basically. So we switch on the name. So we get the name out of JSON. It says, I'm giving you this member. We switch on the name, and static for each from all the members that we can serialize, and write a case statement. So we're actually just generating the case statements. And for each one, we call the implementation that's appropriate for that. Say we visited it, and then we break on the switch. Now we kind of need that label there, because if you don't have that label, static for each complains. And then if it gets a name that's not in the struct, you throw an exception. So this is what I'm saying, is it gives you really good error processing as well, or it doesn't compile because everything has to be very similar. Finally, we check the visited to see if there's any false. If there's a false in there, then we say, you missed some members. And that's it. So that's basically, how easy it is to write a serializer. I find myself writing serializers all the time, indeed, just because it's so easy. But let's move to another type of generative code that's not serialization. I'm going to show you some VibeD magic here. So if you want to expose a D API in the web with VibeD, you want to use all available information, map the names intuitively, and where custom behavior is needed, just use a UDA, just like we're doing with serialization. So let's say we have a simple web API here. The web API, we're going to say it lives as /WH. That's the base route. And all it's going to do, all this class does is basically store a map of one string to another string. So there's the path. Here's our data storage. That's it. And this is interesting. So you have this function called getIndex. Now, what VibeD is going to do is say, you know what? That says index, so that's going to be your route. And I see there's get on the front, so I'm going to use get as the HTTP method. So it's already reading stuff that I didn't have to tell it. I didn't have to tell it anything. I just wrote this function, and it knows. Oh, that's how I'm going to map this thing. The HTTP server response actually comes from VibeD, but it's optional. So if you have an argument in your function that's an HTTP server response, it says, oh, I have one of those. So it's kind of like dependency injection. I'm going to give you that thing. And basically, this part at the bottom is a diet template. I'm not really going to get into that, but basically, VibeD will take a completely different language and translate it to D at compile time and then compile it, which is pretty amazing. And you can actually have D code in your diet template, and it knows what items is. It knows how to access that, which is pretty cool. If we want to post an item, so now post, obviously, we're going to use the post method. And item is the route. Now we could see we have two things. The response is now at the end, so it doesn't matter what order you put those arguments in. It just knows, oh, I got to pass one of those guys in. Where does name and value come from? Well, name and value, it's going to expect to be in the form. So in the form data, it knows, okay, there should be a form value or the query string. There should be a form, key named name, and I'm going to pass whatever value it is as a string, and the value, a key named value, and I'm going to pass that value in. Now, if I called an int, then it would try and convert it to an int first. So it's doing all this boilerplate for me. I don't have to do any of that stuff. I just define my function, and Vibe knows how to call it based on an HTTP request. And here we're just setting the name to the value and going back to the index. Here's an even trickier thing, actually taking a piece of the route and it's passing that in as the underbar name. Now we have to use the underbar because if you don't do the underbar name, it still wants to try and get it out of the form. That's one kind of an annoying thing, but it's all right. I'm willing to live with that. Here we're checking for the name, if we have it. All right then.
Your attention, please. Your attention, please. You are required to leave the building immediately.
Awesome.
Leave by the nearest exit. Disperse into the local area.
All right then.
Do not run.
Thank you very much.
Leave now.
All right, so I can say that my talk is definitely the hottest one in the conference.
That is a bad joke, and you should feel bad.
I do. I feel terrible.
You're on fire.
All right, so we could see here that they pulled the name out of the route. Let me try and speed up things a little bit here. What if we want to add authentication? This is one thing I didn't actually know about VibeD until recently. But it supports this. So basically, we're going to describe a struct that encapsulates our authentication state. The only state we have right now is a username. This is terrible authentication. Don't do this. Basically, I'm saying if your username is root, you can be an editor. And I'm saying if you want to view this particular item, then the item's name has to start with A, which is it's completely nonsensical, but it's just for demonstration here. So all we have to do is add requires auth to our web handler. This is actually a separate route. So I have two classes. I'm actually going to show a demo of this real quick. I might skip the demo, though. So this is all we have to put in our class. Don't ever do this. We're basically getting the username from what the person passes in their form data. But this just gives us some token that we can use to now say, is this person authenticated? Normally, you would get it from cookies or whatever. Get index, we're going to say, you don't have to have any authentication to use that. It's fine. Here, we're saying if you want to edit something, you have to have the role editor. What Vibd does is it says, oh, I see that you wrote editor there. I'm going to call the function called isEditor in your authentication info that I grabbed from your other function, which is really cool. Like, I don't have to do any of that stuff. It just does all that for me, and I just have to name my functions the right way. Same thing with item name isViewer. Now notice that the name is going to be passed into that isViewer function. And because it's named the same thing, it knows where to get it from. So how much time do we have?
Just keep going, mate.
All right. So I'm not even going to give the demo of Vibd, but it's not that impressive anyways. It's just saving names and tokens and editing HTML. But anyways, so fixing the drawbacks. So one of the things that's a problem with generative code is that it is a compile time killer. So when you generate all this code, I think Robert mentioned it as well, it can really, really slow down your compilation process. Just the default Vibd installation takes 4.5 seconds to compile on my 2014 Mac. That's without compiling the base libraries. That's just the application, which is really, really slow, unfortunately. And that's without any diet templates or anything. So but it's doing a lot of generative stuff in underneath. CTFE and templates are suspects in compile time bloating. I'm really, really hoping that new CTFE will fix a lot of these issues. But the lesson from this is avoid the boilerplate. You're using the decompiler. People are bad at writing boilerplate. They make mistakes. It's boring. It's easy to get this wrong. So let the compiler do what it's good at. Avoid it whenever you can. Compilers are much better at it. Have the compiler write your boilerplate. It knows everything about your program, and you can teach it. This is how I would do it. And it works really well. And finally, that generative programming is really the crown jewel of D. It's the reason I always come back to D if I want to do anything, because I can just write a serializer in 2 minutes, and it works. And it's not complicated, not hard to understand, and it just does exactly what you expect it to do. So anytime we have any barriers that are preventing people from doing generative programming, we should try and fix those. So you have a decompiler, go use it. Thank you.
All right, he actually finished on time, even with that little bit of exercise. So would anybody have some questions here? Or you're all out of breath from the stairs? Come on, questions, questions. Anyone? Yes.
You had mentioned before a little bit about Java. Are you coming from a Java background as well?
I have used Java, not recently, but just when I thought of serialization, I thought of Java because I remember that being a big selling feature of it. Is like, oh, you can just do RMI and serialize this stuff back and forth.
Do you also have experience with the Spring framework?
Your attention, please.
Holy crap.
The fire alarm system is now fully operational.
Really?
Please obey no further alarms.
Our machine overlords, ladies and gentlemen. Did you have anything
I'm
else
sorry,
you wanted to say?
Spring, I'm not familiar with that framework. Sorry.
All right, before the fire alarm interrupts again, I think we can get another question in. Anybody? Should we just cut our losses and go get lunch? Yeah, all right, you all look hungry. Thanks again, Stephen.
Thank you.